All right, so in this section 13.1 we're talking about probability, and remember probability is expressed as a fraction favorable over total, and so favorable is what you want and total is the total amount of possibilities. So if you express that fraction, then you'll have the probability of something happening. It also can be expressed as a decimal or even a percent. Okay, so what we're asked to do on the first problem is find a point chosen randomly on segment AD, and we want to find the probability of various things happening. So here's my segment. So I have 4 points on here, and the links between those points are given to us, right? So I want to find the probability that a point chosen randomly on here is on segment BD. Okay, so remember when you're expressing probability, it's going to be favorable, what you want over total. So in this case, what do we want? We want to land on BD. Well, how long is it? 6 plus 4 would give me 10. That's your favorable amount. That's the top part of your fraction. Now, what's the total amount of space it has to land on, the entire segment, which is 6 plus 4 plus 2. So that's 10 out of 12. And remember, with probability, you always want to reduce it down, so the answer would be 5/6. 5 out of 6 chance landing on segment BD. That's your probability. If you wanted to make it a more practical number, you could turn it into a decimal and then turn the decimal into the percent, and then you could see, you have a so many percent chance of landing on it. Okay? All right. What about the probability that the point is not on CD? All right, so what's your favorable amount this time? Not landing on CD. So if you don't land on CD, then you got to land on here somewhere, which has a combined length of 8. So that'd be 8 out of 12. The total amount is still the same. And so that reduces down to 2/3. You got a 2/3 chance of not landing on CD. Okay, so what about the probability that the point is on AB or CD? AB here, CD here. If I add those two together, my favorable amount is 6. Total amount's not going to change, which is 12. So you've got 1/2 chance or 50% chance of landing on it. All right, so again, probability favorable, what you want over the total amount. Okay, so probability problems can be expressed in different ways. So like, for example, this time we have a chart that we're looking at, and it says, let's say this is a spinner and you're spinning the arrow. What's the probability that it lands on yellow? Well, yellow is 60, and this is expressed in degrees. So that'd be 60 degrees out of, if we add all of these together, we would come up with 360. So it's 60 out of 360 total. Probability of landing on yellow, reduce that down to 1/6. You can divide both of these by 60, or like I pointed out to you the other day, there's an automatic fraction reducer online, if you just Google it, that will help you to reduce those more quickly if you have trouble. All right, so when the numbers are big, you may want to use an automatic fraction reducer. Okay, what about the probability that it lands on blue or red? Blue is 90 degrees, red is 120, so I need to add those two together to get my favorable amount of 210. And again, still over 360. Which means that's going to reduce down to 7/12. All right? So again, we're expressing, for this section, we're expressing the probabilities as a fraction. Okay, so what's the probability that it does not land on green? Well, green takes up 45 out of the 360. So if I do 360 minus 45, that is the space for not green, which happens to be 315 out of 360. Or when you reduce that, you'll get 7 out of 8. So remember, probability is always favorable over total. What you want divided by the total amount. And then don't forget to reduce your fraction down when you're done.